What's happening, dogs? Mr. Allen here. We're about to simplify the rational expressions and list any domain restrictions. Now, for my domain restrictions here, since this is all multiplication, I just can't have 0 for my x, for my y, and for that z. I'll list it at the very end. Let's get to simplifying. Now, personally, I like to look for any simplifications while it's a whole mess like this with my numbers so they don't get too crazy large, all right? So, for example, I know that 16 and 4, that can be reduced down to a 4 right here, right? And then also, that 12 is divisible by 4, isn't it? It is. It gives me 3. Oh my goodness, 3 and 3 are gone. All of my numbers right there are gone. That's dope. I could have done 4 times 12, which is 48. 3 times 16 is 48. And see that it would become 1, right? But sometimes those numbers get really, really big and it's non-calc, so it helps to go about it in that way. Now with my variables, I like to put everything together and then simplify. Otherwise, it gets to be kind of chaotic. So I have x squared in my numerator. I've got y times y to the 10th is y to the 11th. And then I have z, okay? My denominator, I've got x. I have y times y to the 4th, that's y to the 5th. And then I have z to the 6th. Now I've got everything nice and organized, right? And I can go ahead and subtract my exponents here, right? Because when I have like bases, the method, or the shortcut, if you will, without writing everything out, is subtract my exponents. That's the rule. So 2 minus 1 gives me 1. I'm going to have, in my fraction here, an x in my numerator. Then I've got, let's see here, y to the 11th over y to the 5th. 11 minus 5 is going to give me y to the 6th. And then I have 1 for that z right there, right? 6 minus 1 is 5, but because the larger one is in my denominator, we get z to the 5th right there. Beautiful. All right, didn't need that whole fraction there. I also got to list my domain restrictions. X cannot equal 0. We got y cannot equal 0, and z cannot equal 0. All right, beautiful. That's dope. That's awesome. We moving on, dogs. We moving on. All righty, same kind of process with this one, man. Same process. Let's see if we can do any kind of simplifications here. Let's see here. 2 and 10, that could be reduced, right? That's going to go down to a 5er. All right, and then that's about it for that. So I've got 6 in my numerator. Then we have a. We don't have anything to combine right there, so we'll just do a to the 4th, b, c squared over, and I got 5, my denominator. Nothing with a. Okay, that's fine. B and b squared is going to give me b to the 3rd, and then I got c to the 4th. All right, that's dope. Now we can do some simplifications, right? You don't have to do it this way. This is the way I like to do it. I'm the guy making the video, so I'm going to do it how I want to do it, all right? How I think it's best. I think this is the best way, man. All right, fraction. I know I got 6. I know I got 5. That ain't going nowhere. I've got a to the 4th over a to the 1st. It's going to be a cubed in that numerator. I've got b to the 1st, b to the 3rd. 3 minus 1 is dose, 2. It's going to be b squared in that denominator because that's where the larger exponent was. And 4 minus 2 is 2, c squared in my denominator. Beautiful. I do have to list once again, a, b, and c are all present in my denominator, so they cannot equal 0. A cannot equal 0. B cannot equal 0, and C cannot equal 0. Now, let's say for fun that this a wasn't in my denominator. That would obviously change some things here, but it would also not be needed in my domain restriction because if a is not in the denominator, having it 0 doesn't really matter, right? So if it's not present in the denominator, it does not need to be listed as one of my domain restrictions. But there we go. 2 dope answers, 2 dope problems. You guys are dope. I think I'm kind of dope right now. And have a great day.